Hello YouTubers, welcome to my video. In this video I'm going to show you this oscilloscope. The brand is Kenwood. The model is CS-5130. At first I thought the 30 here represent the bandwidth, which is 30 megahertz, but when I read over here it's written 40 megahertz. So I think somehow the Japanese should number their test equipment better. So yeah, it has a readout ability, and it's a two-channel oscilloscope. The controls are situated or located or positioned very well on the panel itself, whereby this is channel 1, this is channel 2, and this is the time per division, and this is an area that I don't quite understand. This is the horizontal thing. This is the cursor, so I don't think it represents cursing or what. And I already turn on the scope. Let's see the trees. By the way, this has a stack knob which controls two intensity of the display. The front one control the intensity of the trees. The behind that knob is for the readout display. So currently we are on channel 1 AC, and the volt per division as seen on the rotary switch itself is also displayed on the screen itself, so you don't have to like look at two places at the same time. And let's plug to the calibration point to see at least the wave or the traces. So we are currently on channel 1. Some scratchiness over there. The calibration frequency is 1 kilohertz. It's a square wave with a 1 volt peak to peak. So if I try to do some math, so it's displaying two boxes. One box is 0.5 volt, two box is 1 volt, so more or less correct. And yeah, it has a and B time division, which I don't understand. So yeah, this is the coupling, ground reference, DC, AC, and the position up and down of the channel 1. This is the mode if you want a channel 2 alternate, which alternately display both chop. I don't quite understand what is chop, and add. So they say this add is a math function, so I don't bother about that. And let's plug in both of the channel there, so we can see two traces at the same time. So yeah, okay, let's equivalent the volts per division for these both channel, and let's position the channel 1 below and channel 2 on top. So let's increase the intensity and play with the time signature. Yeah, and this is the position. Let's go back to channel 1. This is the position of the signal of the trace itself, and on where you want to see, whether you want to see full width of the whatever is available to display on you, or you want to see some extra, whether there's some hidden over there or hidden over there. And so that's my understanding of it. I don't like to use complicated word because I don't know much about electronics. This is the triggering level. So in short, triggering means you want the signal or any signal to stay still, so you can read or see and do some calculation. And this blue box over here is, I only understand about this trigger. I don't understand about this. Normally I set this to auto. So normal, I believe auto is much more better than normal. Fix, I don't think I think auto is still better than fixed. Single, I don't want single, I want auto. And reset, I don't want anything that I have to reset. So next to it is the source. It shows vertical mode, channel 1, channel 2. I don't know whether I should set this to channel 1, because when I set it to vertical, it doesn't seem to interfere with the my measurement. It seems to display everything right. Channel 2, line, I don't know what is that. External, maybe to partner with another oscilloscope, could be. Next to it is the coupling, AC, and I only set it to AC. HF HFREJ, I think HF reject, if you want to reject some or you want to reject all of the high frequency. I don't know why you have to do that. DC, normally I set it to AC. TV frame could be to measure a frame of a television or what. TV line could be to measure the line of a television. I think there's 525 lines for some system, and then 625 line for the other system. Could be related to NTSC or PAL, something like that. So I don't bother about this area. Normally I push the switch to the top. Seems to work for me. And one thing about old oscilloscope, I like this. I like this a lot. I like this flickering. Can you feel that? It's very satisfying. It's like I'm a guitar player, so I like to play with the selector of my guitar. So having this on the test equipment gives more satisfaction. So next to it is the horizontal control, which is we have A, alternate, and B, and XY. So very nice. So one thing about XY activation on this scope, I find it very ergonomic and very easy to activate. Is some scope you need to pull something here, something there, or something over there, then only you can get the XY activation. On this scope, you just go to XY, everything is XY. So it also shows you, or you are on XY on the display. Next to it is the cursor. Currently is off. If you do normal, I think if you do normal operation or usage, you should set it to off. However, you want to do some measurement of the currently we are on the volt measurement peak to peak. You can play with this and play with the bottom line, and then there's some math equation going on between these two lines that gets you the total volts peak to peak. So it's very convenient, but I don't use that. And the other cursor ability is to measure the frequency. So you can more or less measure from one point to another, which more or less is in accordance to the calibration frequency itself. So yeah, I don't have to use that. This button, I do not know. This two stack knob, what does it do? I do not know. And what more? Yeah, this is the focus. This is the illumination, which I don't have to use because if you look, it's quite ugly. So I don't like this. Looks like a very cheap and gonna blow oscilloscope. So normally I turn it off. So I like dark background to better see the signal itself. And I'm gonna hook to my function generator, and let's look at some other variant of sine wave. Okay, let's increase the intensity. Let's decrease the volts per division. Let's adjust the sharpness. Currently on sine wave. Play with the amplitude. Play with the frequency. Sawtooth, very nice. See, very sharp. Square wave not so nice because maybe my function generator the adjustment is out a bit, which is yeah. I think I've explained much about this oscilloscope. It's a It was released, I believe, in the 90s, and I think this is a very expensive oscilloscope at that time because of the readout ability, and it's very nice to me. It look very nice because when I first saw this scope on eBay, it looks dirty from the picture, but when I got it, it's very very beautiful. So it should be that way, because if you're selling something on eBay, you should take ugly picture of it, and then when the other guy receives it, he's gonna be very happy because it looks beautiful in real life. So yeah. So yeah, I think that's it for today. I think I've attempted well in explaining what I know about this scope, and thank you very much for watching. Have a nice day, and as always, bye bye.